Okay, the blue region is the area in question. It's bounded by x equals 9y squared, which is the top half of the parabola, x equals 9y squared. The y-axis and the line y equals 1. That's the blue region. We're told to use the method of disks to come up with an integral for revolving that region around the y-axis. Okay, I'm going to get some smaller stuff going here. There we go. So this black strip represents a typical disk that is going to be revolved around the y-axis. So this is actually the radius of that disk. And if you have a disk, think of a coin. Its volume is the area of the base, which is pi r squared, times its height, which is going to be represented by dx, or in this particular case, dy, because these typical disks are going to occur along the y-axis. So when you're using the disk or the washer method, your typical disks or washers are perpendicular to the axis of revolution. And so here is pi times the definite integral from a to b of f of x squared dx. This is like the radius of your typical disk. So, and by the way, you have to find this point of intersection out here. And we know this is the line y equals 1. So when y equals 1, x equals 9. So this is the 0.91. So these typical disks are going to occur from 0 to 1 along the y-axis. And we could have the pi as part of the integrand, but it's a constant, so we usually put it out front. The radius is, for each y, the distance along here is a horizontal distance, a y distance, an x distance. So 9y squared is the radius. And we want to square that. And of course, there's the dy. And you could write that as pi 0 to 1. 9 squared is 81, so you could put the 81 out here, and now you're finding the antiderivative of y to the 4th dy. We'll look at that, what that is, evaluates to in just a second. If you're going to use the shell method, this red strip represents a typical shell wall, and the formula that you have to use is 2 pi times the definite integral. In this case, I put dx here. You could use a shell method along the y-axis also, but in this case, our typical shell walls are going to be occurring from 0 all the way out to 9. But the question is, what is the height of this shell? Well, just this part right here is the shell. And to get the height of that shell, the y-coordinate at the top is always 1. And then this distance, if we solve x equals 9y squared for y, we get y equals the square root of x over 9. That's what this distance is right here. So 1 minus that will give us the height of the shell. And then the average radius is the distance of that shell wall from the axis of revolution. So it's that distance right there. And that's just an x distance. So the height of the shell is 1 minus the square root of x over 9, which we will write as 1/3 x to the 1/2 when it comes down to evaluation, times the average radius, which is the distance, again, from the axis of revolution to the center of the shell, dx. So there's your two integrals. Here's what they look like. This integral evaluates to 81 pi over 5 and gives us this decimal approximation. And 2 pi integral from 0 to 9 of 1 minus square root of x over 9 x dx, same thing. Okay, so both the disk and shell methods give the same answer. If you were going to actually evaluate that second one, you'd probably go like this: 1 minus square root of 1/9 is 1/3. Write the square root of x as x to the 1/2. And then distribute that x 0 to 9 of x minus 1/3 x to the 1/2 times x to the first is x to the 3/2. That's a 2. And I'll just take it a little bit further. Antiderivative of x is 1/2 x squared minus 1/3, raise the exponent by 1, would be add another 2 halves onto there, multiply by the reciprocal of the new exponent. And we're evaluating that from 0 to 9. And it might not look like it, but if you evaluate from 0 to 9 by putting 9 in minus putting 0 in, you do get 81 pi over 5. Okay, there you go. Hope that helped. If you have any questions, post a comment.